Hello, Algebra students. Today we're covering 6-1, rational exponents and properties of exponents. So rational means that we can write a number as a fraction. So we'll circle that word rational and remember that it can be written as a fraction. And our learning target is we're going to extend properties of integer exponents to rational exponents and rewrite radical expressions using rational exponents. So we're taking what you know about exponents and we're just extending what you know. We're going further with what you already learned in 8th grade with exponents. And a radical expression using rational exponents. We will also be solving equations with rational exponents using the properties of exponents. So a rational exponent is an exponent written as a fraction. Engage and explore. We want to make sense and persevere. So describing two ways to express the edge length of a cube with a volume shown. And the volume shown here is 2,500 inches cubed. And we want to know the edge length of the cube. So I'm going to pause the video right now and I want you to talk with your group about ways that we can describe edge length with volume if the volume is given. Okay, so how do you come up with the length of a cube if you're given the volume? Talk about that amongst yourselves and then we'll come back and share. All right, for those of you at home, in case you weren't part of our discussion, volume of a cube could equal the side lengths cubed. Or another way to write volume is the volume is equal to length times width times height. And so if they give us 2,500 and we write it as this, the side length would be side length cubed. And to undo the cube, we would take the cubed root. And I don't know if you've seen this before, but basically it's like a square root with a cube on it. And when we cube root the s cubed, taking the cubed root undoes that and we get s. And there is a way to put this into the calculator to figure out what that equals. And then length times width times height, we can't really solve for length times width times height unless you know that the length, width, and height are the same thing, which would bring us back to the original way that we had. Okay. Example 1. Write radicals using rational exponents. What does 3 to the 1/2 equal? 3 to the 1/2. So you can think of exponentiation as repeated multiplication. What this means is, this is just a little review, 3 squared means 3 times 3. And 3 to the 3rd means 3 times 3 times 3. And 3 to the 4th means 3 times 3 times 3 times 3. So what does 3 to the 1/2 mean? We could go backwards and say that 3 to the 1st is just equal to 3. And then 3 to the 1/2, that's a little tricky. But we can't really say 3 times 3 in halves, 3 times 3 times 3. We can't really say it like that. And so the opposite of exponents are square roots or radicals. Okay, so that's like a radical is a square root or it could be a cubed root or a fourth root. So that's how we would write 3 to the 1/2 with a radical. It would equal the square root of 3. And when it's 2, we don't actually have to put the little 2. It's just implied. Okay, so that is our answer. 3 to the 1/2 is equal to the square root of 3. And you could put that in your calculator to get an irrational answer. All right, let's move on to our try it. What does 2 to the 1/3 equal? Explain. I'm going to pause the video now so that you can talk in your groups about what you think 2 to the 1/3 would equal. Okay, so in your groups, did you talk about the to the 1/3? So we would also write it as a rational exponent, like so, but we would put a 3, as a radical. Sorry, I don't know what I was saying. I was reading, but the word I meant to say is this is a radical. So the square root or the cube root, those are radicals. And if we have time, I will show you how to put this into the graphing calculator, 2 to the 1/3, to figure out what it would approximately equal, because it would be a decimal answer. And I think that online calculators will do that for you too if it's a scientific calculator. Example 2. Use the product of powers property. So this is something you should have learned in 8th grade, the product of a power. And what this property says is that when multiplying two powers with the same base, we add the exponents. So let me give you an example, or a couple of examples. We have 3 squared times 3 to the 3rd. Well, that would be 3 to the 2 plus 3. We would add the exponents. That's what it's saying. If they have the same base, the base is 3, we add the exponents. And this is going to serve us with our algebra. You choose black. You could also have a variable such as a to the 4th times a. And when there is no exponent, we are going to assume that it is 1. So it will be a 4 plus 1, which would equal a to the 5th. And sometimes they might have fractions, which is what we're going to get to in this section, because we are extending what we know about powers. So when you're ready, turn the page. Okay. This is example 2, use the product of powers property continued. So on the last page we talked about what the product of powers property is, and now we're going to apply it. We're going to use it. So here we have 3 to the x over 2 times 3 to the x over 3. So since they're both a base of 3, we can add these exponents. We're multiplying them. Since there's nothing in between, we assume it's multiply. X over 3. So I took the exponents and we are just adding them together. It helps us simplify this. And that's going to equal 3 to the 9th by just bringing this part of the equation down. If you notice, both sides have 3 as our base. And so, since we can get rid of the bases, this is a property of exponents or powers, and we can just rewrite it as x over 2 plus x over 3 is equal to 9. So the 3's canceled out and we're just left with adding the exponents. That comes down, and then the 9 comes down. Okay, and now we have to solve this, and this is going to be a little bit tricky, but I think you guys can do this, and this is also going to prepare you for those one-step equations quizzes that have fractions. So the denominators are 2 and 3. We can't add unlike denominators, so we need to come up with like denominators. So I'm going to write x over 2, and I'm going to multiply it by 3 over 3. And that 3 came from this 3 here, that denominator, plus x over 3, but I'm going to multiply that one by, can you tell me? Yeah, 2 over 2. And that is going to still equal 9. So what we're doing right here is coming up with a like denominator. So 2 times 3 is 6, and 3 times 2 is 6. So find a common denominator. We'll write that in the notes. Find a common denominator. All right. From there, we will just simplify it. So we will multiply, and that becomes 3x over 6, and this other one becomes 2x over 6. We add, and that equals 9. Okay? Now that they have like denominators, we can add. Okay, so that step that we just did was simplify by multiplying. And then we're going to add these. And that becomes 5x over 6. Actually, I'm going to write it up here because I'm running out of space. 5x over 6 equals 9. Now, if you remember from last year, hopefully, to undo a fraction, and maybe I'll write the x separate so that it's easier to see. 5 over 6x. It doesn't matter, you can write it with the 5x on top over 6, but to undo this, we are going to multiply by the reciprocal. That's what I was saying, hopefully you remember from 8th grade. Multiply by the reciprocal, and that undoes the operation. So I'm going to multiply by 6 over 5, multiply by 6 over 5. This cancels, leaving us with just x. 9 times 6 is 54, so it will be 54 fifths. And you can leave it like that, or you can write it as 10, right? 5 goes into 50 10 times with 4 left over. Okay, don't let the fractions scare you too much. And we're going to do try it in our groups right now, and then we'll go over it. And then for those of you at home, you can pause the video, try it, and I'll put the solution here, but in class we will do it together and fast forward this part. Okay, now that you have had a chance to try this, I will go over the answer for the people at home. So these bases are the same. We will write this as 2x to the 4th plus x to the 6th, and that will equal 2 to the 3rd. Since they're the same base of 2, we can write the exponents equal to each other. And then we can find that common denominator. So 4 times 6 is 24. So the common denominator will be 24. And we multiplied 6 on the first one. So we have 6x over 24 plus 4x over 24. And one way that I kind of remember that is we just kind of move this one up here, multiply this one over here, and then multiply across to find the common denominator. That will equal 3. Now we just need to add. So that will give us 10x over 24 equals 3. And I noticed that I can reduce this. So to make my multiplication easier, I'm going to reduce 10/24 to 5 over 12 by dividing each by 2. Now I will multiply by the reciprocal, which is 12 over 5. And that cancels those, leaving us with x equals 36 over 5, or 5 goes into 36 7 times with 1 remaining. Okay, that is kind of some complicated math, but I think with some extra practice, maybe rewatching this video and trying these problems again and again until you can do it without the video, you will be able to get this. All right, for example 3, we are going to use the power of a power property. The power of a power property states that if an exponent is being raised to another power, you can multiply the exponents. So, for example, what if we had 3 to the second to the third? What that would mean is that we would have 3 to the second times 3 to the second times 3 to the second. And we have 2 plus 2 plus 2, which is 3 to the sixth. We could have just skipped the step using this power of a power and just multiplied the exponents, because 2 times 3 is 6. So let me show you that in another example where we skip the middle step. So maybe I have 5 to the 4th squared. We would just multiply those exponents and get 4 times 2 is 8. And with a variable such as, let's use the variable d to the third to the 1/3, 3 times 1/3 is just 1, so d to the first, which just equals d. So that's something you should have learned in 8th grade, but if not, there's a quick review. And now we're going to apply it. All right. So starting with A, we have 27 to the x minus 4 equals 3 to the 2x minus 6. Well, in the last example, we could just get rid of the exponents because they were the same. But in this, or not the exponents, the bases, we could get rid of the bases because they are the same. But in this case, we have a base of 27 and a base of 3. Well, those are not the same, but I do know that 27 can be factored. 27 is 3 times 9, and 9 is 3 times 3. And if we draw a factor tree, hopefully you've seen this before, I kind of like these, we get 3, 3, and 3, which means 3 to the third. So now we can make these look like they have the same base by writing 27 as 3 to the third, because it was 3 times 3 times 3. And I'm going to put that in parentheses, x to the minus 4, because that was that exponent here, x to the minus 4. Okay, so all we did was we wrote 27 as 3 to the third. Then I'm going to bring down the rest, equals 3 to the 2x minus 6. Now they almost have the same base, but that 3 is a problem. So if we remember from our property, we can multiply these exponents. So I'm going to distribute that 3 right here to the x and to the minus 4. We're going to multiply those two out. So 3 times, well, let me first write the base 3. 3 times x is 3x, and minus 3 times 4 is 12. That equals 3 to the 2x minus 6. Now, you can see that the bases are the same. So we can just write 3x minus 12 equals 2x minus 6. That's just using the exponents, rewriting it as just the exponents, and the base goes away. All right. Phew. This is some complex stuff, and you guys should feel pretty smart for being able to follow along with this. Now, I need to solve this. So I'm going to subtract 2x. I'm going to get the variables on one side. That leaves us, this cancels. This becomes just x. X minus 12 equals, this cancels, negative 6. The next step to solving this equation, add 12. So x equals 6, because negative 6 plus 12 is 6. Awesome. Now we need to do b. All right, for this one, we have 1 over 125, and we have 1 over 25. Unfortunately, we're going to have to factor both of these. So 5 goes into 25 5 times. And 5 times 25 is 125. And 25 is 5 times 5. So we can see in this factor tree that we could rewrite these with a base of just 5, or 1/5, because it would be 1 over 5 to the 3rd power. And then this one would be 1 over 5 squared. And then we're going to raise those to the power of the exponents that they originally gave us. Right here, we have to put those exponents there with it. So it would be 3, and since we're raising it from a power to a power, we're just going to multiply these powers. Times negative x over 2. Sorry, got a little sloppy. 3 times negative x over 2. And 2 times, I'm going to put it in parentheses because it's 2 parts. So that just came down from the exponents. We just brought these down, and we're going to multiply them by the powers because that's the power of a power property. All right, so 3 times negative x over 2. We're going to multiply. That will become negative 3x over 2. And since the bases are the same now, we can just get rid of the 1/5. We don't need those anymore. And then 2 times negative x is negative 2x over 3 minus 2. Okay, now we need to solve for x. So I'm going to get variables on one side by adding 2/3 x to both sides. Oh, we don't have a common denominator. So we're going to have negative 3x over 2 plus 2/3 x. That cancels, equals negative 2. We need a common denominator. So I'm going to use that trick where I multiply across. And I'm going to multiply this one across. And then the common denominator will be 2 times 3. So 3 times negative 3, that's that arrow going to the left, that'll give us negative 9x. And 2 times 2 will be 4x. And it's going to be over 6 for that common denominator. That's going to equal negative 2. Oh, I'm out of space, so I'm just going to work backwards, come up here. Negative 9 plus 4 is negative 5. So I have negative 5 over 6x equals negative 2. Now I have to multiply by the reciprocal. So that'll be negative 6 over 5. Multiply by negative 6 over 5. Canceling, leaving us with x equals 2 times 6 is 12. 12 over 5. Or 5 goes into 12, 2 times with 2 remaining. So 2 and 2/5. So this is tricky stuff, lots of steps. I recommend re-watching these videos and practicing these. And then tomorrow we will do a little bit more practice with this type of problem.